Hello, everyone. This is Alex from ThursdAI and Weights and Biases, obviously. I'm recording this after the show to give you a brief recap of what we talked about so you'll know the contents of the show, because today's structure was a little bit different than the previous structures that you know and love. So I'll go through a TLDR of topics that we've covered and the things that happened in the AI world super quick and let you know that we had an interview with the Haize Labs folks about their library of LLM as a judge called Verdict. So this is the TLDR for February 20th, as the show is recorded from the AI Engineer Conference in New York, the summit, AI Engineer Summit in New York. And I'm here, and for this reason also, the podcast will be lightly edited, unlike usually, and also the newsletter will be also lightly edited. So let's get going. In the open source LLMs, we covered Perplexity's fine-tune of DeepSeek R1. They call it R1 1776. It's a fine-tune of removing Chinese propaganda from the model. It's a fairly controversial take, and especially as I asked some of my Asian friends, they don't love the kind of the heated debate about this. However, they selected like 300 examples of topics that Chinese government usually considers forbidden and remove them from the model. So if you want a model that can answer what Tiananmen Square is all about, you can try this one. And they did this without losing any eval's performance. So pretty cool. Arc Institute and NVIDIA introduced Evo 2. Evo 2 is a new genomics model, and it's state of the art. It's around 40 billion parameters in size. It was trained on 9.3 trillion nucleoids for over 128,000 genomes, diverse range of species across all domains of life. It uses striped hyena as an architecture. It was released in open source, trained with NVIDIA and Arc Institute together. It can process genetic sequences for up to 1 million nucleotides in length, which is super cool. If you're into genomics models, this is definitely one to check out. We also covered a new benchmark called Zero Bench, which is the impossible benchmark for VLLMs. They came up with a bunch of examples that the current top-of-the-line VLMs are getting exactly zero at. And also we covered the Hugging Face released an ultra-scale playbook, which is a way for folks to learn how to build big clusters with a lot of GPUs in them. And Microsoft also released OmniParser, which is a computer use library that basically shows every actionable item, button, or anything on your image. Very similar to computer use from Claude, but this is an open source model and looks very, very good for Microsoft. So those are things in the open source LLMs or VLMs. We also had a bunch of video stuff. So we've covered Microsoft Muse, which is playable worlds from one image or 1 second of video. This is incredibly cool, and I suggest you go and look at the videos of this. They developed it in collaboration with Ninja Theory, and it's based on the WAM architecture, World and Human Action Model architecture. They trained on 1 billion plus gameplay images for 7 years of continuous gameplay data and from real Xbox multiplayer matches. So basically you take 1 second video of a gameplay and then you can keep playing this with your controller. It's quite something. We also covered 2 breakthroughs in video, including one state-of-the-art model from StepFun. So StepFun released Step Video 2v2 and 2v2 Turbo. And it's a state-of-the-art 30 billion parameter MIT licensed text-to-video model. It looks really, really good. It's also fine-tunable. And we also talked about Fast Video from Hao AI, which is a distillation of HY video, Hunyan video, which we covered before. It just runs 3 times as fast. So instead of 15 seconds, it runs 3 seconds. And it uses their new sliding tile attention mechanism that reduces the inference, and it doesn't require any fine-tuning. So it's really, really super cool. We also covered in breaking news that the company Figure that does humanoid robots recently discussed that they're leaving OpenAI integration, and they announced Helix, a vision action model built into the Figure robots that runs in a System 1 and System 2. One of them is a 7 billion parameter pre-trained VLM, probably a fine-tune of Quen or something, we don't know, that actually does the vision language semantic reasoning. So you can talk to the robot and you can say, hey, pick up the butter and give it to the other robot. And then they also have a System 1, which is a 80 million transformer that they trained in-house that runs on a separate GPU, and that runs at 20 hertz per second and does all the movements. They have a video where robots are doing things that they haven't been trained on, and you tell them, pick up that thing, and it does pick up it. But also the robots are handing it to each other. So they have a shared way of running this Helix model on both robots, and it's super, super cool. We also briefly mentioned that Microsoft announced their new quantum chip and a new state of matter that they connected to this thing. It's called topological superconductivity, and I found it like absolutely mind-blowing that they announced something like this. So definitely worth checking this out. And we also talked with folks from Haize Labs, Leonard and Nitin, about Verdict. This is a conversation with Leonard and Nitin from Haize Labs about Verdict, their framework to compose state-of-the-art LLM judges with judge time scaling, which is a new thing for me. And given that this is an area of interest, I went fairly deep. So if this is interesting you, definitely check out the conversation with Leonard and Nitin on the rest of the show. So probably like an hour in the conversation with them. In this week's Buzz, I covered that we're about to launch an agents course. So that 1b.me/agents, you can already pre-sign up. And we talked about the workshops. I have a talk tomorrow. So depending on when you hear this, 11 a.m. Eastern on Friday during AI Engineer Conference, I'm going to talk about LLM Reasoner judges. And also there's a link to show the whole AI Engineer track, which is free and you can tune in. The biggest thing that we've covered in the beginning, obviously, is XAI releasing Grok 3 on a Monday. So some of you who tune in, they already know that I've already covered this, but we've covered kind of the vibes and everything they released, including reasoning and deep search. And so we've covered this at the beginning for almost, for a good chunk of the podcast. And we also covered the fact that OpenAI is about to open source something. Sam Altman posted a poll and asked whether or not we want a mobile optimized model or we want a O3 mini level model in the open source. And also, they started to have a rivalry about evals. XAI posted something. OpenAI said, hey, we don't post stuff. There are like best of 64 runs. XAI fired back and said, yes, you did post a best of 64 runs, etc. So there's like a little bit of a debate about evals, whether or not Grok is the smartest model in the world or not. But we try to stay away from the controversies and focus on what actually was shipped. So this is pretty much everything we've talked about on the podcast. I really enjoyed the conversation with Leonard, and I enjoyed the conversation. We had some friends of the pod from before, actually, and Nistan came back in the middle of it as well. So a great podcast. I encourage you to listen to it, although slightly less edited because I'm on travel conditions and I need to run to AI Engineer and prepare some stuff. With this, thank you for tuning in, and then enjoy the show. All right. Welcome, everyone, to ThursdAI. I'm Alex Volkov. I'm your host for today and have been your host for the past 2 years. I'm an AI evangelist with weights and biases, which you can see by me wearing this cool-ass jacket that my colleague Sam made for all of us. We are here tuning in live from New York. As you can see in my background, there's a water tower. I'm right on the least favorite part of the actual New Yorkers, which is Times Square. People don't actually come here, but as a tourist or somebody who visits not that often, it's very cool. And I am here for the AI Engineer Summit, Agents at Work. Engineer is, for many of you maybe don't know, is where I got my start as a media person, somebody who does podcasts. So shout out to Benjamin and the whole AI Engineer Summit team, or generally AI Engineer team. It's live right now, so actually after the stream, I will encourage you to go and watch this. And I'm assuming that we're going to have a little bit of a less of a turnout today because many of our listeners, AI engineer enthusiasts, and they are definitely watching and tuning in. So this makes perfect sense. So we may even tune in for some of it during our show. But I know that many of you are here to get your news for the week, as our motto is we stay up to date so you don't have to. And so this is what we're going to do. We're going to cover everything that we found notable or noteworthy from this week in AI, and we're going to talk about it. We're going to read through some reviews. We're going to share some vibes. And by we, I mean me today. But also I do have an interview coming up later in the hour with Leonard from Haize Labs, Leonard Tang, and so that's going to be very, very interesting. We also have a Weights and Biases corner as well. If you are tuning in and you are at the Engineer Summit, I love when folks who listen to ThursdAI come up and give me a high five. So I shake hands with new people and I give high fives to listeners of ThursdAI. So please do not hesitate to come and talk to me about whatever you do and what I can do on the podcast to actually make it better for you. I actually ask it for many people. I was like, hey, what can I do to make it better? And people are like, nothing. You're perfect. And I'm like, that's not true. Come on. Are you listening to the full 2 hours? No. So this means there's something there to be done. With this kind of introduction, I want to say a few kind of starting words. First of all, the podcast is sponsored by Wits and Biases Weave, which if you're in the Twitter space, you can see the square, black, colorful icon, which I will now invite as a co-host, so it will help me. So shout out to Weave for helping make this work. But also, we don't have any other sponsor. So the best way to support us, which is great if you want to do that, is first of all, if you're live on X or live on Spaces or whatever you are live with, come to this comment section on YouTube, on LinkedIn, on X, and just give us a comment, participate in the show. It's very, very helpful, especially when I'm co-host less sometimes, like today. But also, I would say give Weave a follow, obviously. And the other way to support us, if you want, is to go wherever you get your podcasts and give us a review, a 5-star review. Before you give a 4-star or 3-star review, talk to me and tell me how I can improve. But after that, leave a review, absolutely. Those are the best ways to host, to help support the podcast. All right, let's get started, folks. I think like the biggest news of this week was obviously happening on Monday. Those of you who follow me closely already hopped on the space. We're on the space live. Some of us on Monday, we started our Monday with a President's Day. Some of us didn't have kids, didn't go to school. The XAI team just worked throughout the weekend. And we've been talking about XAI working very, very hard for a while. And we were waiting for Grok 3. I was actually surprised that Uncle Elon is actually releasing Grok 3 at this time. I was very surprised. Grok 3 was actually announced and demoed and then released fairly quickly to many, many people. So let's talk about Grok 3. Should we watch something? No, we shouldn't watch something. Let's just talk about it. A few folks, Igor Babushkin, Jimmy Ba, and I forgot the third dude's name, and Elon Musk all sat down in a very similar to OpenAI announcements setting, very, very similar one, and announced their latest and greatest state-of-the-art, at least on some metrics, those are debatable, we're going to talk about this, LLM that was trained on a whopping 100,000 H100s compared to the previous one, which was Grok 2, which was okay, but not that impressive, was trained on around 16,000 H100s. And so they announced their great new, state-of-the-art LLM. But not only that, like we expected, they also talked about reasoning and agency and agents, etc. So that was super cool. So let's try to break it down. Although we did not get a technical paper or anything, so I don't even know the context length of Grok. I hear it's big, but I don't know how big this is. They didn't actually mention this anywhere, which is interesting because we're used to the way things are happening, but this didn't actually work out. So let's talk about, and folks, in the comments, I would love to hear your thoughts about it as well, because, well, the jury is still out. The vibes are still vibing, and I promise you a recap on Thursday, and since Monday, I've been trying to play with Grok a lot. But then Igor Babushkin from Grok said, oops, we had a bug, and some of you got Grok 2, although the drop-down picker showed Grok 3. So if you thought Grok is lame, this could have been this bug. So that confuses things even more. So all of the people on our timelines who complained about Grok or said, oh, it's not that great, they could have just received Grok 2. We're getting a live reaction here that says, a developer has said that it's a 1 million token context, but in the app it's limited. I haven't seen this myself. I would love a source for that, actually. Rodri, thank you for giving us this comment. I would love a source for 1 million token. I saw someone said that the token size is huge, but I didn't see a confirmation from the folks. So let's talk about what we actually got in Grok 3. We got a new frontier LLM that does incredibly well on benchmarks. So let's take a look at this. They mentioned benchmarks at the beginning. They mentioned benchmarks of the non-reasoning Grok, and they talked about MMLU and MIME. So let's take a look at those. And then they also mentioned the reasoning part, right? Grok beta, actually, I want to see the evals without the think, because those are interesting. All right, we're getting impressive results on stuff like GPQA, for example. So GPQA is definitely great. Google Proof QA, which is PhD level understanding. Okay, we're getting a source. That's awesome. On GPQA, Grok is receiving incredible results, very impressive results. We're getting 75% GPQA on Grok 3 beta and then 41 on Grok 3 mini beta. Compare that to 32% of GPT-4o and 36 of Gemini Pro. Very impressive results. I actually like also maybe I'll show this. Yeah, I'll show this. Give me a second. I want to show you the stats here on the video as well. So we're getting impressive results, and also I kind of like the way they present them as well. So you can hover over like each little column and like the column highlights. So whoever did the UI for this one, I appreciate it. As somebody who reads eval tables, the UI for this one is very appreciated because not always they're state of the art in bold. What else do we have? We have MMU Pro, which we know is saturated. Both of these models that are like 78, 79% with GPT-4 at 72%. And I believe that this is without the reasoning. Oh, wait. Okay. Yeah, we have a confirmation. It is 1 million context windows. Okay. On the official blog, context window, 1 million tokens, 8 times larger than previous models. So thank you for folks. Roger, you were correct. We got a confirmation, a context window, 1 million. That's impressive. This is a big model trained for a long time on a very big cluster. So this makes perfect sense. And still very, very, they also posted long context evals, loft evals for 128 context. Grok achieved a state-of-the-art accuracy, which is great. I haven't heard about Loft benchmark before. We talked about other ones, but I haven't heard about Loft. They also announced that they have been trained on LM6 Arena under the name Chocolate, under the code name Chocolate, and they're now topping the LM6 Arena at around a 1400 ELO rating, which is the first time any model broke through 1400 ELO rating. I will say that we have been talking about LM Arena for a while, and sometimes there's signal there, and sometimes it doesn't really correlate because Cloud Sonnet 3.5 is way, way lower in the Arena, but still many people swear by this model still to this day, even though it was released trained 8 months ago. And so Arena doesn't really show this, and Arena shows Gemini model, and I know some people don't trust Gemini models, although I do love them. Arena is not necessarily the best representation of Haize, but it's definitely there's signal there. And 1400 ELO score means that many, many people just significantly preferred Grok 3 on top of everything else. And what the XAI folks claim that this is an early version of Grok 3. Early means they keep training this, and they released a version that's smart enough, but this is definitely not its final form. Very, very interesting. At this point, I would love to invite some folks in the comments to tell me, what's your experience with Grok, folks? I'm actually going to be okay with inviting some folks on stage here because I want to hear. And let me see if I can invite a few of my mutuals folks that have been playing with Grok. So if you're a mutual, welcome to step up. But I've played with it, and here's again the kicker. I don't know if I played with Grok 2 or Grok 3 because they had a bug. And if I did, it's not a very, it's an impressive launch, don't get me wrong, the model is impressive, but the fact that I don't know whether or not I played with the right model and I'm not able to tell you my experience if it applies, it's sad. But we can actually try this live because I tried it live on the live stream and it didn't work that well for me. Grok is now launched for free, by the way. You can choose Grok 3 beta from the dropdown, and Grok is now free. They said that they will offer Grok for free for the foreseeable future until their GPUs melt, and you can access Grok on grok.com, and actually you can see it through the Grok interface. I want to test Grok on the question that I always have, which is Bev's Ice Cube, and I did test it. And you guys know this question from AI Explained on YouTube. I used this question on Grok 2, and it absolutely failed it, and it was hilarious the way it failed it. So I really want to see grok.com, and it's hilarious that it failed it because the thinking got to this question multiple times. You can definitely see the Grok is super fast, even without the thinking part, and we're going to add the thinking part as well. Yeah, now that I'm getting Grok 3, I'm still receiving wrong answers. You guys know this question. For the folks who are not watching, I'm going to read this question again. Beth places 4 whole ice cubes in the frying pan, and then it goes into very unnecessary detail that says at the start of the first minute, then 5 at the start of the second minute, and then some more at the start of the third minute, none at the fourth minute. The average number of ice cubes per minute placed in the pan while frying a crispy egg was 5. How many whole ice cubes can be found in a pan? So basically this question doesn't really matter. If you read into it, you understand that the second you place a ice cube inside the pan, they melt. So the question at the end, how many whole ice cubes are remaining, is confusing because all of the LLMs are trying to be very helpful in the calculation, go deep into the math of the rate of melting. But if you read the question as a human, you're like, well, ice cubes melt even if you leave them on the counter at room temperature. Ice cubes will absolutely melt in a frying pan that fries an egg. There are not going to be any whole ice cubes, so the answer is 0. But this tricks LLMs to start calculating, and they give you calculations. We've been testing out on this and other questions, so the logic, the real-world understanding of LLMs, and Grok has failed this one, and it's unfortunate. After Grok announced, and now we know that's 1 million context window, Grok also told us about there can't be a model without reasoning in 2025, right? So they've announced Grok with reasoning. They call it Think. There's a button there that says Think. And this one shows you the thinking traces. And this is a reasoning model that was trained on verifiable results, kind of like with the same RL as O1, as R1, as Quenquil, as like all of these reasoning models. And you can see the thinking. Elon Musk confirmed that this thinking is not the actual traces. They're doing the same thing that OpenAI does. They are not showing us the full traces. For those of you who are watching right now, you can see the thinking like flies, but it overthinks a lot. And even on this question, I think the couple of times that I played with this, I saw that it got to the right result and then kept confusing itself and kept thinking about whether or not it's right or wrong. So it's interesting that I've seen the right result show up and then still nothing, like the model arrived at the wrong conclusion. So that's very, very interesting. From the, let's see what we actually got. Let's see if we got the right answer. So I kept asking Grok, and now I've turned this on with reasoning, and yeah, we got the wrong answer again. Answer C, 20. Assuming the frying process spans 4 minutes, Beth placed 11 ice cube, blah, 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 and both average condition, yeah. It's really, really bad. Nope. I will tell it no, and then hopefully it will try to figure out why not and then answer. We've tested other questions like this as well. So on these questions, at least, the vibes are not great. I want to confess, I went to O3 Mini, which we were celebrating a while, and O3 Mini was just launched from OpenAI to big fanfare. O3 Mini also fails this question. Although O1 preview and O1 gets this, and I think even GPT-4 sometimes gets this. Is this your experience, folks? Is this your experience with Grok as well? Because I've seen folks turn around on it. And this is why I'm saying the vibes are split. We actually have Akshay here. Akshay, have you had a chance to play with Grok? What's your take?
Hi, Alex, after a long time.
Yeah, you haven't been here in a minute, man. How are you?
Yeah, I'm doing good. I did play with Grok a lot, and only for coding. So sadly, nothing else. And thinking mode off because I don't like the thinking mode at all. I prefer the Gemini thinking mode or O3 Mini for that matter. But with just the base model of Grok 3, it's, in my opinion, it's the best coding model out there. And this is considering that I don't do web-related coding. If you do web-related coding, I think 3.5 Sonnet is still better. But if you do AI coding, so if you write a lot of Python, especially if you deal with cutting edge stuff, so like something that has come recently, stuff like that, I think Grok 3 is just really better than anything else out there. Before this, I was using Gemini for this because their knowledge cutoff was pretty recent and they can get the updated stuff from internet and stuff like that.
Yep.
So yeah, that has been my basic understanding by far. Maybe I'll have to switch from Gemini to Grok for my coding stuff, but that's been pretty cool by now.
That's very interesting, man. Thank you for chiming in. Thank you, Akshay, and great to have you here and chiming in to ThursdAI as well. Again, folks, if you're mutuals and you've been on the podcast, you want to share your experience with Grok, I'm still collecting vibes. So you're more than welcome. I see Morgan, I see Noah, I see like a bunch of folks, Ishan. Let's get back to some of the stuff that they announced. They announced the thinking mode, where you can see the streaming thinking tokens. And then they talked about some evals that are compared to from the thinking tokens. And I actually want to run through those evals because then I saw a debate about those evals, and this debate is very, very interesting. Let me see if I can pull up no, that's not what I want. Give me a second, folks. I want to show you the windows. Okay. Why can't I Give me a second, folks. 1 second, please.
The funny part about the new evals is that XAI has also started posting very weird graphs. So if you notice, the way they plot the graphs, the scales are different for each plot, right? So they make you seem the difference is larger than the numbers suggest, right? Like it went from 87 to 90, but the bars for these two will be completely different. Google used to do this, and people used to call out Google on this. And even Musk, I think, had posted a few times trolling them. And now XAI has done the same thing with their latest evals, and they have completely left out O3 from their evals, which they should have included.
Yeah, so we can talk about this.
Just wanted to mention it.
Because they did release a state-of-the-art model, and then they did not add O3. But then also I saw some comments saying that O3 was not released yet and may not be released as well. So the omittance potentially makes sense. I saw this. You're right. There's a whole conversation about the cattiness. I don't usually love to cover this, but the cattiness started happening with Boris from OpenAI and Aidan McLaughlin, that's now in OpenAI as well, started calling out some of these graphs, specifically the graphs that add the reasoning and also the graphs that add best of n scores. So I think here's one example of this conversation. Basically, somebody said that the lightly shaded parts of the evals, so on AIME 25, AIME is competition math, they showed a specific example from Grok saying that the model generalizes, and it's not that they just trained on this data, because AIME came out like a couple of weeks ago, or at least this part, and they showed a impressive 93 results out of 100. 93 out of 100 means they solve 93 out of the 100 questions, or 93% out of 100%. I'm not entirely sure what they're showing. Then there's like two bars on the same bar. There's the regular colored bar that gets up to 75 or something, and then there's a lightly shaded part of the same bar that goes all the way up to 93. And then somebody posted and said, hey, the light blue part is actually best of n, which means the Grok 3 reasoning is like reasoning for multiple times, and then they select one of the 64 for examples, and they show that without this best of n, this is the same model as O1 level, which that's not what Elon Musk wants to say. But then some other folks chimed in and said, hey, OpenAI, you guys also did this. You also showed us best of n for AIME, because we're not looking at one shot only. We're looking at models that can do multiple things and then get to the right result. Like very similarly to Weights and Biases trying to get to best of SweBench, which we talked about, right? Sean, the CTO of Weights and Biases, did a lot of iterations to get to that level. But basically, people started to talk about whether or not these vibes are correct. And then XAI folks said, you OpenAI did the same thing with O3, O1 and O3 as well, but not O3 mini specifically. There's definitely conversation about this, and some people are very salty about the way that OpenAI treats, some folks publicly from OpenAI treat the conversation now that they've potentially lost the leading run, at least for a little bit. Now, back to Grok, I'm trying to see, and I asked yesterday, there's a bunch of very smart people here in the AI Engineer Summit in New York. I tried to collect vibes. You would be surprised how many of them never tried Grok before. This could be the result of, not specifically, this could be the result of people not trusting. Somebody asked me yesterday if Grok is full of Elon Musk policies, and it was a very interesting question.
Yeah, I just wanted to mention that I have had Premium for a long time, like Xperium, and I did not use Grok at all. Not at all. I would rather use Quen 1.5 billion on my local system than use Grok 2. But Grok 3 will probably change it. And it seemed like a nice trolling model and conversational model, but it was not a nice problem solver or a coding model, right?
Yep.
That seems to be changed with Grok 3. By far, in the past few days, I have found it very helpful with coding. And yeah, I'm right now using it with coding. I hope it comes in on all the IDEs, so Cursor and VS Code, hopefully, so that we can truly experience what it's capable of. But till now, the vibes are that it's finally a problem-solving model. It was not before. It's finally now.
Yep. And I should mention that API, they mentioned that API is coming, but there's no API right now. So even on the inability to evaluate, right? Like right now, we're not able to plug this in and test for ourselves whether or not the evals that they're giving us are correct, which is something that we usually love doing independently. So right now they released the model. A model is available on x.com for, I think, everyone right now. So they first released it to Premium Plus subscribers. Then they also announced a tier on Grok.com. But then they currently do not have the API access for it. So we're not actually able to use this model to independently evaluate this model and to tell you guys whether or not they actually told us the truth. Actually, I would agree with you. Like this, I've used Grok before, and I mentioned this multiple times in the podcast. I use Grok for real-time information access, and I think it's unparalleled at this, specifically because it has access to X info at real time. It also has access to Reddit and like a bunch of stuff. And similarly to this, I would also say the thing that they released is deep search, right? So you guys remember deep research from OpenAI that's now still available on the premium, the $200 plus plan. That's definitely something that we've been covering. It's OpenAI's agent. And when the Grok XAI team in the announcements got to the agents part, they said, hey, we also think about the agentic future. Our first agent is the research agent. Very similar one to Perplexity, similar to deep research as well. They check a bunch of sources, they reason through them, and they kind of like go deeper. Although I did have funny responses with this one. I called it shallow search because I asked for something fairly complex where deep research from OpenAI gave me 11 minutes and 17 sources, and Grok searched for all of 34 seconds. And they gave me a result that I called shallow search because it was kind of not very impressive. I want to welcome Nuo as well. What's up, Nuo?
Hey, what's up, Alex?
How you doing,
It's been a long time.
Yeah, it's been a minute.
Yeah.
Thanks for joining us. Nuo is the dev advocate or open source advocate at OpenAI at Ye Models. And welcome, man. What's your take on the situation? Have you played with this? What are you thinking?
Yeah, so I've been trying with this Grok new thinking method, and I think I have some very interesting observation. It feels like more like a scratch pad rather than thinking. So I'm actually comparing it against the DeepSeek R1. And I think the R1 to me more like someone who is talking to himself inside his brain. So it's more like someone talking secretly inside their brain, while Grok feels more like a scratch pad. It doesn't make me feel that it's like reason and then the output. And however, if we really compare with the GPT-o3 Mini, it feels like something also different. So the O3 Mini tends to not overthink about things, but those two tends to overthink about things. So that's one of my very interesting little observation that I have.
I agree with you. It absolutely overthinks. As on my kind of questions, I saw it, and I think I posted about this. I'm actually going to add this to the show notes. I posted about this. It got to the right answer and kept thinking, and multiple times, and maybe 4 or 5 times. I haven't seen this before. Like almost 4 or 5 times, I've seen the the right answer show up, and it's been a pain to read through this. No, you're almost there. No, you're like, you got it. No, and you didn't get it. So that was upsetting. But yeah, generally I think it's a good model. It's been trained for a big amount of time, 1 million context window. Now we've got it confirmed. We're just waiting for the API. So to recap Grok 3, one thing that I will say, they claim that this is not its final form. They also claim that they will keep releasing better Groks. I tried to ask Igor Babushkin somewhere whether or not they're going to version this for us, or will they just replace the model that's on production and we won't know and we'll just receive a better Grok. I did not receive an answer, so waiting for this answer. Also, as we talked about and Elon Musk promised, the previous version will get released in open source. So they confirmed that once Grok is stable and live, we'll get Grok 2 as open source. I predict, and this is not my prediction, it's Ivan's prediction, I think it's dope, but I also don't necessarily think that everybody's going to be excited to run this. Like, it's probably going to be huge. It's maybe an MOE, and so I doubt that like people will actually run this. But the commitment to open source is worth noting and shouting out. So we're looking forward for that open source Grok 2 coming out soon. I think we've covered Grok enough, unless there's more things that you guys want to put in the comments. It feels like we've covered Grok enough. I want to run through some updates and also introduce our guests for today's podcast as well. And we're going to go from there. Let me actually run through some of the open source stuff that we have to cover. Briefly, we're at least going to run through them. And then I want to introduce our guests as well. in the open source area, which we're going to cover in a minute, we have a very interesting attempt from Perplexity. They call it R1 7076, which is, for those of you who haven't seen Hamilton, this is the year that the Declaration of Independence was signed, I think. Yes, Declaration of Independence. So basically, the year of the United States independence. They fine-tuned what they call, I believe, the Chinese propaganda out of R1. I think they didn't go as far as this, but I think their CEO did, at least on X. They said a version of DeepSeek R1 model that's been post-trained to provide unbiased, accurate, and factual information. But basically, they did say, like, this is like very specific to Chinese government and One China principle, and they want to have this model reply that Taiwan is not part of China, etc. So they try to make sure that R1 gives accurate answers according to Western principles. And so they show some examples of asking about Taiwan independence and asking about Tiananmen Square, etc. And then they talk about some post-training. The approach there is very interesting. They employed human experts to identify at around 300 topics. So I know of one or two, but they went all the way to 300 topics known to be censored by the CCP, and they built like a censorship classifier, and they trained those out and got a data set of 40,000 multilingual inputs and outputs to train out of this model. So it's very, very interesting that they have the ability to remove censorship from a model via post-training. I want to hear from Nuo on this. Nuo, what's your take on this 76 approach from...
Yes, I would say, first of all, DeepSeek, they work in China, and they have rules and regulations to follow.
Sure.
I understand that. I also noticed that R1 is, to some extent, filtered on some topic. So I'm not that against this work, but I would actually prefer that they can actually disclose more of their details in terms of post-training, because it's very interesting to see how they describe their methodology. It's very vague, like how they prepare the data, how they actually increase the size of data set, and how they fine-tune. Because running the R1 model by itself, it's already very difficult and very expensive. And fine-tuning such a model, it's actually, if the number they show is correct, if they only fine-tuned on such a small, I would say pretty overfitted data set, and I'm not seeing a severe decline in terms of all these different metrics like MMLU and mass. So I'll be extremely surprised to see how they do that. So I would hope that they can actually disclose more details. But unfortunately, it's no. So yeah.
Yeah, so on MMLU, they barely have a decline. So 90.8, they get to 90.5. Very, very small decline. On math, they basically are like almost the same. They even got a little bit more on AI.me, but that's probably variance from 79.8 to 80. But yeah, I agree with you. We need to know more about this. But very interesting attempt as well, because I do know that many people do not appreciate the kind of the non-Western kind of leanings of R1. Although I don't think that they only were able to train on the stuff that they know. It's possible that the model is leaning elsewhere in other areas as well.
Yeah, unfortunately, that's the world we live in right now. So we have to deal with it.
Yeah.
So I think one of the things also that might be interesting. So if Perplexity really have that much resources in terms of research, then I think one of the things that should have been doing is to start from continual pre-train. So to my knowledge, so in order to prevent those unethical or let's say unlawful content from showing up, so the pre-training corpora has gone through some kind of topic clusterings and some kind of filterings. So basically they're doing is to overfitting in the SFT stage, but if they can do somehow from the pre-training stage to add some corporas that is different, I think that's going to be more thorough as open source work.
Yep. All right, we're moving on. Actually, we're moving on, so I'll ask you to comment on something else, because we do have some guests here that I want to introduce in a second. There's a very interesting evolutionary genomics model from Arc Institute and NVIDIA called EVO2, and this is like fully open with two papers, not one, two papers. There is weights and data and training and inference code bases. So basically, we love to see these attempts. We've talked about evolutionary models before, and this one seems to be kind of state of the art as well. Trained on 9.3 trillion nucleotides, so not tokens, nucleotides from genomes. And they use striped hyena, which we talked about before as well, to process long genetic sequences and to enable analysis of complex genomic patterns. And NVIDIA, I think they have a platform of theirs called BioNeMo, and NeMo is the platform, BioNeMo is like the biological aspect of it. They can accurately predict the effects of genetic mutations, including other regions as well. As I've mentioned before, I'm very excited about evolutionary stuff. Genomics, evolutionary, and bio models. I'm very excited to see like the kind of transformer and transformer alternative architectures getting to these models as well. This is a 40 billion parameter model, Evo 240B. It's available on Hugging Face. If this is something that you're into, it's very, very worth checking out. And shout out to the folks for this incredible effort. Two other things super quick on the open source. I'm sure there's more, and we will get to the video part after the interview. There's a bunch of stuff there, including Muse, etc. But in the open source, there's a new benchmark called Zero Bench, where it's called the impossible benchmark for VLMs. And they basically say that all of the current VLMs get 0 on this benchmark. And you can see like an example of this. The very basic example, they have like a bunch of letters like scattered, and they say, answer the question that is written in the shape of the star among the mess of letters. And I'm not sure, looking at this myself, that I can see which star they're talking about. So very interesting kind of like visual benchmark, because we need more benchmarks. But at this point, 0% of VLMs are able to get to this. And the last thing in open source, which is very, very cool for at least for some folks, Hugging Face released the Ultra Scale Playbook, which is training LLMs on GPU like huge clusters. They ran 4,000 scaling experiments on up to 512 GPUs. Of course, nothing close to the 100,000s ones that the XAI team talked about at Grok release. But basically, they released a playbook for a guide for building and scaling ultra large AI models and key considerations, best practices, data, etc. So shout out to Hugging Face. And if you work in a lab that wants to scale your own, this is definitely a great resource. Yeah. All right, folks. I think with this, let me introduce our guests for today. Let me make sure that they're here. We have Nimit and we have Leonard from Haize. What's up, folks?
Hey, guys. Good to be here.
Hey, Leonard. Welcome back. Leonard, you've been here before. And then Nimit, I don't believe you've been here before, but maybe I'm misremembering, but I don't believe you've been here, right?
Nope, it's the first time.
Awesome. So welcome, folks. I will let you introduce yourself maybe briefly, and then we can talk about some exciting stuff that you released before we continue with the rest of the show, because I want to be mindful of your time here. But also, I'm very excited about the stuff that you released, because I'm also like looking into this. Leonard, how about you start first?
Sure thing. Yeah. And Alex, I'm very excited for your talk tomorrow on judges and evals at AI Engineer. So excited to see you in person.
Yeah.
Cool. Real quick intro on myself. So I'm Leonard, one of the co-founders at Haize Labs. Very much steeped in the world of AI evaluation and reliability and robustness. Spent the last 5-6 years of undergrad and a little bit prior to undergrad thinking about these research problems. Ultimately, skipped out on a PhD to start Haize. And if folks aren't familiar with Haize, Haize is a AI reliability and evals company. People probably best know us for our red teaming and safety testing work with a lot of big frontier labs. But we also think a lot about what does evaluation look like in a world where everybody has a very different definition of good and bad, and everybody has a very different AI application and use case for models. So that leads us to a lot of our work with Verdict, which I'll let Nimit explain.
Yeah. And Nimit, how about you give us a little intro for folks who haven't heard you on the podcast before?
Certainly, yeah. Very excited to be here on the podcast. I'm Nimit. I'm a member of technical staff at Haize Labs, working a lot with Leonard. And before this, I spent a few years in the quant world. So I left, started to get into this space over here, and it's been super interesting. So like Leonard said, we're thinking a lot about the problem of aligning these judge models to like customers' specific needs. A lot of the papers in industry tend to focus on one particular benchmark or set of benchmarks, but a lot of times in real business use cases, the distribution is shifting all the time, right? So we want to think about how can we use very large foundation models and compose them in different ways to continually adapt to users' new needs as they come along. And so we built Verdict in-house as part of this set of experiments to try to understand how far can we push this inference time compute and how aligned can we make it.
Yeah, I want to follow up on this because it's very interesting to me, and also like I researched a bunch for this like upcoming talk, like I mentioned. So folks who are listening and are in New York, you're more than welcome to like tune in. Actually, it's also live on YouTube, so I'm gonna add the link to the show notes. And if you're watching on Thursday, you're welcome to tune in as well, and let me know what you think. Leonard, last time you were here, we talked about attacks and universal jailbreaks and by bijection. I believe that this is the latest research. How are you connecting the two pieces from the universal jailbreak world? And also, I saw you guys were cited on the recent Anthropic universal jailbreak kind of mitigation thing that we also covered. How are you connecting from that world of like mitigation and safety, etc., into the world of LLM judges? Can you make the connections for the audience?
Yeah, for sure. By the way, the constitutional classifiers paper was a lot of fun to co-author. Bijection learning was actually developed more or less as a way to try and defeat that system. Yeah, because it's input-output classifiers, and so if you can obfuscate the input and output classifiers, and you succeed. But yeah, so of course, Haize is primarily known for red teaming and attacks work. But when you think about automated red teaming, you need to have a success condition, right? You need to be able to monitor the input and outputs to whatever target system you're testing, and know actually whether or not you've successfully jailbroken that system, which is not a straightforward problem, right? In traditional functional verification land, you have things like branch coverage, code coverage. You have things like you can actually just directly cause a seg fault or cause a set of unit tests to fail. Or if you're in the smart contract world, you can actually infiltrate and perhaps actually get some money. So there's something very tangible and measurable that you can produce as an artifact to understand whether or not you've succeeded in your testing. But in AI land, it's much less obvious, right? And people generically have been using things like patterns to try and see if there's an exact match on certain strings, or using simple LLMs as a judge to determine whether or not the output of an AI system is, say, harmful or sufficiently harmful. A lot of what motivated us to pursue judging and reference-free evaluation more was just that our red teaming algorithms were not like too much by prompt search or prompt optimization. It was mostly like we could search really well, but what a judge considered to be a harmful response was actually not practically harmful, executable, or grounded in the real world. And so we decided, okay, we should probably just solve the first task of defining what is a good and bad response before we try and optimize with respect to that metric.
Awesome. For folks who are tuning in and maybe have not a lot of ideas about like evaluation generally in the world of AI, I'll do the very brief recap. There's basically three ways for folks to like evaluate. Like you said, there's no unit tests for these models. It's impossible to unit test them because of the stochasticity, because of like different temperature, etc., because of complexity of agents, for example. And so what most of the industry now does is one of three things. They either do programmatic evaluations, they try to do with regex, like you said, or other ways. If your model returns code, they try to run this code and see if the code passes, etc. There's also humans in the loop, where people actually look and use, I don't know, you pay a lot of money to Scale AI or some other companies, or you and your technical staff, you do it yourselves. You read through the model responses and you like try to judge them and write them in like an Excel sheet or somewhere. And there's also the more robust and scalable way, which is these models. Many models are great actually at judging the other models on outputs. And so you give them some conditions, some criteria, and you try to get these models, what the industry lovely calls LLM as a judge. For listeners of ThursdAI may remember the last AI engineer, I showed up as an actual judge in costume and talked about LLM as a judge. And people now call me the judge because of it, including Hamel. But LLM as a judge are problematic. They're problematic for multiple reasons, which we'll now talk to. How about you take us into the world of like why and some examples of like why LLM judges are programmatic?
Certainly. Certainly. To start with, LLMs as a judge have all the same issues that LLMs have to begin with, right? They're super sensitive to the prompt to begin with, right? For example, if you ask an LLM as a judge, is A a better response or is B a better response? The order in which you specify A or B actually matters a lot. There's a huge correlation that most models, including models that are public, that are released and new and fine-tuned and tuned very well, they'll prefer A over B regardless of what the content is. Models will tend to prefer longer responses over shorter responses. And perhaps most interestingly, models will tend to prefer their own responses that they've generated out of their own distribution compared to other models. So if you're, evaluating the output of an AI system that's, interacting with a customer, for example, it will prefer content that it's generated on its own. So you have to be very careful when aligning these models of these insidious distributional biases that all these LLMs have to begin with. And it's compounded even more by the general structure of these LLM as a judge prompts and techniques that people use. So out of the box, LLM as the judges don't really work. They have a ton of pitfalls that you really need to be aware of and very carefully think through and try to mitigate.
This last one I called, some folks refer to as nepotism bias, right? So the models actually, I found it really funny, and this is a good way to remember this. Like GPT-4 would prefer GPT-4 outputs, or like that family of models, maybe not O1. And then you have to do some stuff to at least know about this, and then try to mitigate this. And so this, in the vein of what you guys announced, ThursdAI is not a regular podcast where I invite guests of interest and ask them about just the general stuff. We talk about what happened this week. So can you connect the dots for me? What happened this week and why you guys are here? And let's talk about Verdict.
Yeah, awesome. So real quick, Nimin and I released yesterday Verdict, which is our library for scaling judge time compute. So judge time compute is this new notion, right? Of course, we've had at this point 2 iterations of people pushing scale. So we've scaled pre-training compute, we've scaled inference time compute. But to us, as we think about where AI is headed, it's not necessarily generation that's the hardest problem, right? It's more about how do you prune and rank and filter and select the best examples at test time for your particular use case, right? And so again, that comes down to the evaluator, or in this case, people call it verifiers for test time compute or verifiers for word models or whatever have you. Right now, we have not really pushed that far beyond formal settings like programs or mathematics with these verifiers. And what we're thinking a lot about is how do you get a little bit softer, richer rewards in non-verifiable settings, right? And we think that actually pushing compute for the judges themselves, so just using more compute in the judges, is one way to get those rich rewards for your particular setting. And so concretely, what we released is this library, fully open source library that lets you stack together different primitives and patterns derived primarily from the scalable oversight literature, from the generative reward modeling literature, from the critique modeling literature, in ways that basically let you get O1 or O1 plus performance for a fraction of the cost. So you can think of it as we're scaling inference time compute for judging, but with very strong architectural priors that lets us be very efficient in how we use tokens.
I love that. I want to follow up on the scaling stuff. That has a very straight up definition, at least in the way I think about this, right? Of always added chain of thought prompting to your models and kind of receive chain of thought back. The update in recent times with like inference time compute is that this kind of happens inside the model itself because it was trained with RL and now the model knows how to do this. And then you can provide like more and more time to think or to inference, let's say, and then the model basically reliably gets more and more correct on the data. But this is not necessarily what's happening here, unless is it? Like, if I want to understand correctly, what do you mean by judge time compute, which I love, judge time scaling? Can you clarify what this means? Are you using reasoning models under the hood for this, or are you not using reasoning models, but trying to get to the same results by approximating what's happening within the model, but with just like some infrastructure?
Yeah, that's exactly right. It's very much the latter. So I don't know if you actually, Alex, remember that sort of 2D plot of performance versus latency and cost.
I have it.
Maybe if you want to pull it up on the tweet thread. But yeah, the idea is very much that you could certainly use reasoning models as judges, but they're very expensive and they're relatively high latency, which in the grand scheme of things, maybe is actually not terrible. You may be just like 2x, 3x training speed. Nonetheless, it is still very expensive. And so a lot of what we're trying to do is match or exceed reasoning model performance as the evaluator, just by, as you say, stacking infrastructure in a way that is relatively constrained for the task.
Yep. And so we are looking at a chart right now for folks who are listening, where at least on the expert QA judge accuracy, O1 is absolutely kind of the highest cost at least, but not the highest results, right? So it gets around 69% or something. Around it costs like 176 according to what you guys saw. And then Verdict, which is a collection of judge techniques together, in this case, also gets higher score, so almost to 80% at around 50, so around a third of the price. Could you maybe talk to how you got there and why Verdict is the tool that allows you to get there? Maybe you take this one?
Sure, yeah. So concretely, to answer your question, you're asking, do we use reasoning models or do we do something else? And the answer is we choose to do something else. So a reasoning model, you can imagine, would try under the hood a bunch of different techniques, right? It would throw the whole kitchen sink at what might even be a medium-sized problem and not like a large-sized problem. What we actually do in this case where we achieve these results is we ask an LLM as a judge to provide an explanation of their reasoning and a score as well, right? Then we'll take a second LLM and we'll ask that LLM, hey, does this explanation make sense? Is this explanation coherent and logically consistent? Or does it contain hallucinations, right? And now we can use that extra set of supervision and run this experiment, in our case, 3 times, and then take an aggregate of those results, right? So we're basically have decided that the common failure case of the initial LLM as a judge is maybe hallucinations, or maybe it's not answering the task correctly, and we're pruning those results using the verdict system. So we designed a verdict architecture, and then we can just apply that across the whole data set. And now this verdict architecture is our judge. So it's the compound of many different small LLM calls, in this case 4o calls. And in this case, we do 6 different 4o calls, 3 initially, and then 3 verifies on those, and then aggregate the results. So that's what we mean when we say we do compound systems. And you can think of it as one possible thing that an O1 or reasoning style model might do. But we've decided through experimentation that architecture will work the best on our judge task. So we don't have to do the whole O1 reasoning chain. We can just do this much, much faster compound chain that we've designed ahead of time.
Yep. I liked some of the best practices that you guys have added as well, because in this world, especially, and folks who listen to ThursdAI, they know I work at West Biases. We do a tool set for evaluation and visualization as well. So we also research into like how folks approach. The main problem of judges that we see specifically is that how do you evaluate between the judges itself? What's meta evaluation? How do you actually know whether your judge is better compared to like your human raters, or is it just like hallucinating more so you get a higher score, but it's not in fact better? How you test for meta evaluation? How you actually know that the judges are good? You're just doing against expert QA and judge bench and judge mark, all this stuff, or do you have any insights into how folks that actually do want to look at judges and decide which are better, how can they meta-evaluate the judges themselves?
Yeah, that's a really great question. And I think this is actually like the last extant frontier of AI in general. Like I think this final customization, like final last mile customization and adherence of the judge, and then subsequently the underlying model, is a perennial problem. I don't think anybody will solve this in perpetuity. But I think Verdict is an open source library for giving you the potential. It gives you the canvas to apply something, right? To apply a judge model, but you still have to throw paint on it, right? You have to constrain the judge, basically tweak the parameters of the judge to something, right? And so that's a lot of what we think about commercially on his platform. Perhaps worth mentioning it in brief, we have this method called active alignment, which is shorthand for active learning to align judges to human preferences. We basically have this human in the loop distilling a lot of their preferences and taste around a particular response, right? Input-output response. And we use that to update the judge over time, right? So I think that is probably the best way to actually do the meta eval, so to speak, and see how well your judge really aligns for your particular use case. Of course, like the most straightforward and perhaps gold standard would just be you collect a whole lot of data and then do the meta eval on the data set, see how that turns out. But I think absent of this, which is often what we see when we talk to customers, this notion of seeing how often your judge aligns with a human preference on the fly in an online way is also a very, very solid proxy.
Yep. And in our workshop that we also do about evaluation, we're going to talk a little bit about Cohen's kappa and ways to actually do inter-rater alignment, which is fairly standard in at least some of the more, I don't know, binary areas of. In some others, there's some other areas, but yeah, I agree with you. It's a problem, and it's a problem that once you start getting into this problem, you're like, okay, how do I evaluate my meta evaluators? Are those okay? So that's actually interesting because you guys also have this, right? You have one judge that responding, and then you have another judge looking at those judges. So just for folks who are getting confused about the amount of judges, there's the production model that sits on your production, does replies to your users. That could be cost optimized, that could be speed optimized, that could be like fine-tuned, etc. There's the teacher model or the judge that looks at the outputs of your production model, decides whether or not they are according to criteria, which is maybe criteria of correctness, maybe bias mitigation, maybe toxicity mitigation, maybe like a correct summary, etc. Maybe your own evals, which we always recommend for folks building your own evals. But you're saying, Animit, that there's like another layer of verification on top of this judge as well, and the output is the kind of the cumulative understanding of both of these. What are maybe some of the primitives that you guys built into Verdict that allows to do this?
Definitely, yeah. So you explained it perfectly well. I would add that this is just one particular architecture that we found works well for a wide variety of tasks, right? But the great thing about Verdict is like it's a true framework. You can design any architecture you want to. Mm-hmm. Under the hood, we have basically a DAG, just a graph of nodes, judge nodes, or other arbitrary nodes that can do whatever you want them to do. And you can compose them and stack them and align them together however you like. And so, yeah, you asked what primitives we have and what those allow us to do. So for example, you can very easily do things like debate. which is the background of our website. The logo is just a debate going on. You'll have a proponent and an opponent argue about, is this, is this that, is this correct, is this not? And then at the end, you'll have a judge take the output of that conversation and make a verdict, right? Now you can imagine you might want to do that 5 times and take the average of it, or you might want to do that 5 times, then filter them down by some other criteria to avoid some biases. You might want to take A and B and then do B and A and then take the average. You can really compose these however you like. And we hope that the community is going to take this general purpose framework and build all kinds of crazy verdict graphs and find out what works best for their use case. And yeah, there are a ton of ideas from the research literature that we have very easily been able to implement with this library. Super easy to take your graph and adjust it a little bit. We have like Airflow style syntax for actually aligning dependencies. So yeah, we hope it's just a very general purpose framework, basically.
That's awesome. Let's talk about some evals before I'll let you guys go. I want to talk about a few ones because you posted some state of the or near state of the art results. Could you walk me through them and what you think is like remarkable about this? So we're looking at expert QA, and this is like remarkable. You're getting like 10 points above 01, but also you have verdict below this with 4.0 mini. Could you walk me through what this means, the judge unit plus max pool unit? Yeah. What does it mean and how you achieved like a state of the art on expert QA? And also I would love to talk about judge bench as well.
Yeah, sure. So real quick, the actual architecture that we use is 6 LLM calls here. Judge unit, max pool unit. It's really 3 sequences of judge units. So this is what Nimit was mentioning, where you have this initial judge and then a self-verify. We replicate that 3 times, and then we get the final results of each judge, then verify, and then we aggregate that using a max pool unit. Max pool is just max vote. So there's 6 LLM calls in total. When we say parentheses GPT-4o, that just means we're using GPT-4o for all of the underlying 6 LLM calls. When we say GPT-4o mini, that means GPT-4o mini is powering each of those 6 LLM calls. Obviously, GPT-4o mini is not as powerful as GPT-4o, and as you stack GPT-4o, you get less of a good score versus if you stack calls. Hence the 12% discrepancy there.
But for folks who are not looking, it's still better than just like straight up one-shot GPT-4o. You're getting like 76% here versus GPT-4o's 64. And that could be attributed to just like multiple times you're aggregating results.
Exactly.
Mix, yeah.
Yeah, exactly. And it's cheaper. The 6 GPT-4o mini calls is cheaper than a single GPT-4o call. It turns out this particular architecture, this judge, then verify, and then aggregate architecture, just generally works very well out of the box. We just threw it at the expert QA task, and with no particular tuning, we were able to get close to 80% and beat out a lot of the other models on this task.
That's so awesome. Let's talk about judge bench as well. Yep. I've looked into, they are trying to collect examples specifically from STEM related areas, and they are tricky for judges specifically. So they're looking at tricky for judges like tasks, and it's still getting saturated. Like the 01 preview getting 75% on this. Yeah. Even this very, very tricky judging task supposedly is getting already very saturated. With this method, you guys are getting very close to Sonnet 3.5 at 63%. Have you tried Sonnet specifically? How come multiple judgments, and maybe let's talk about argument units as well, how come multiple judges are not getting the same level as Sonnet, for example, here? I would love to know.
It's a good question. We need to do more investigating, but our initial hypothesis is the flavor of task that expert QA is very different than judge bench. There's something very fundamental, which is judge bench is a data set of synthetic generations. The actual inputs and responses are from LLMs. So it's synthetically created, but like manually filtered data set. Expert QA is all human generated. So all the queries are generated by experts, all the annotations, the labels, et cetera, are generated by human experts. So it may be one of those things where, let's say 01 or Claude 3.5 Sonnet has just seen a lot more synthetic data and been trained a lot more on these synthetic eval tasks. It's not unreasonable, right? A lot of people are trying to bootstrap, like Meta has self-taught evaluators, or a lot of other people are trying to bootstrap online DPO their way on top of synthetically generated data. So that could explain the discrepancy in judge bench results versus expert QA results. But that's just, we got to dig a little bit deeper there, but that's the initial hypothesis.
Yeah, that makes sense. I think we're approaching the end. How can people use Verdict, and where is it available, and what are the plans for the future of Verdict?
Yeah, and then you want to take this one?
Sure, yeah. Verdict is fully open source. It's on GitHub. You can do a pip install, and you can get it today. We also Started out as an internal tool that we were using for our own research. And we have spent a good amount of time making some documentation, a bunch of cookbook items, and we've also implemented, I think, 6 or 7 papers from the latest LLM as a judge literature, just showcasing all the crazy things you can do with Verdict. So we hope those are good starting points. We have a Discord, and we're always happy to help answer questions on Twitter about how we use it. And we'll also be releasing the source code of our actual Verdict implementations for the state-of-the-art results we have on our website over the next couple of days. So we hope people just dig in and start using it. And I'll also add that super fast. We have a thread-based concurrency model, lets you run thousands of LLM calls and responses and coordinates them all in parallel, super fast. We can run these experiments blazing fast, either with hosted VLM models or with provider models. We support client-side rate limiting, so you never run into any issues running large-scale experiments. We really hope the community does something creative with it. There are a ton of applications that can fit into any part of a number of different research projects or production projects. And
so I'll go into my spiel here just to connect the dots, because again, from Weights and Biases an evaluation platform, and the whole thing is when I talk to AI engineer developers, they're like, I ask them how to evaluate, and they show me this thing, which means vibes. Vibes evaluation is fine, but folks, you cannot compare the vibes of today to the vibes of yesterday. There's no empirical way to do arithmetic between vibes. You cannot say vibes yesterday were like at 70%. No, you need empirical results, you need evaluations. For this, you need LLM judges, and there's like a bunch of biases, and Verdict seems to be a great attempt at mitigating those biases. One last thing I would love to ask you guys. You did achieve SOTA on multiple benchmarks with the library. You have best practices that you posted. I would love to run through those best practices to just give something actionable to folks who are listening. How to achieve SOTA as LLM as a judge. I think it's on the documentation, but if you guys want to take one of each, or like maybe like a few of the best practices and share with us, that would be amazing.
Yeah, for sure. Maybe real quick before we get there, I do want to point out, like, Verdict judges are very ostensibly for, auto evals, right? Like offline evals, sample evals, perhaps inference time, runtime evals as well. But we do see these judges as being very powerful for not just application evaluation, but yes, as rankers, verifiers, and pruners during test time compute. We see them as being very powerful as reward models during reinforcement learning. In fact, we're training our own reasoning model using verifiers, which I think.
Awesome.
By the way, if people in the audience have tasks that they want reasoning models for that are not in a verifiable domain, please let us know, because I feel like we're just on the cusp of wanting to try this, or like the community is on the cusp of trying this, but there hasn't been a canonical benchmark or canonical task that people move towards. But yeah, you can use Verdict judges any number of things, right? Offline, one of them, inference time garden modeling for reinforcement learning. And then
the biggest point in inference guardrails that I heard coming from you is that if you do use reasoners, for example, guardrails is an impossible task. You will not run a reasoning model as a guardrail because it will take longer than the actual production model. It would make no sense to. It will not be able to block any like problematic thing. You have to have something faster. So getting to the level of reasoner with a fast infrastructure, you said limit it's parallelized, right? So like multiple things are running in parallel. You're not sequentially waiting for one judge and then another judge when you have a summary of them. So that I think is a very interesting approach as well, because guardrails, we've built some guardrails as well. One big consideration is how fast they are, even to the point where LLMs are probably not necessarily the right choice for guardrail. You need to train like BERT or modern BERT specific classifiers, like we said, because LLMs sometimes are even slower. So yeah, that's one definitely big approach. And so basically, Leonard, I get what you're saying. Like Verdict is not necessarily only for offline evaluations. It can be used for RL, and you guys are working on this, and maybe we'll have some follow-up on this. Best practices?
Yeah. Nimit, you want to place through some of them? We can trade on and off.
Sure. I think the biggest point to make is that it's all about the distribution. It's all about the distribution of the models in your pipeline. Like I said, we've learned a lot about how these different models have their own distributional biases. Some of them, they have like mode collapse. They'll say yes a way bigger percentage of the time than no. One thing that we like to do is study like the actual log prob token distribution, as opposed to relying on things like structured output. Not a lot of people talk about this, but structured output imposes its own set of biases on the output, right? Structured output needs to mimic things that's seen in the training data that are also in JSON format or XML format. And those documents have a very different structure than like the space of natural human documents or thoughts or alignment values, right? So it's all about distribution. It's all about making sure that you're studying the distribution of your outputs at every step of the way, similar to a lot of like classical machine learning approaches, and being very careful and making sure you don't get misaligned at any of those stages. So a lot of our SOTA tuning that we did was like studying these things carefully and making sure our models are expressive where we need them to be.
Awesome. All right, folks, this has been great. Thank you so much for coming up and open sourcing Verdict as well. I think it's very important to have. I'm looking forward for some amount of integration from our folks to like show Verdict results with a nice dashboard as well. So I think we have a conversation about this. Meanwhile, I will tell folks that check out Haize Labs. You guys are doing awesome work. I really appreciate it. When you come. There's always something to learn from, and I definitely come from this more. So thank you, Nimi, for coming. We'll continue with our other corners here, but folks should definitely give you guys a follow and then check out Verdict and give us comments about Verdict as well. If you guys, like Leonard said, have a tasks that you want reasoners to do, they're not in verifiable domains, this will be a big unlock once there's RL for non-verifiable results possible to train for reasoners. All right, folks, thank you so much for coming. We're going to continue with our show. And the next thing we want to talk about is I'm sliding into naturally towards this week's buzz super quick, right? So folks who are listening to ThursdAI know that there's a corner that I call this week's buzz where I talk about everything related to weights and biases. Let's do this super quick and then we'll continue with the show. Alrighty, super quick. I don't have a lot to update you on weights and biases corner besides the fact that our workshops are sold out. So I cannot invite you anymore to Toronto workshops that I'm doing in a couple of days. But if you are listening to the show and you're coming to workshops, that's going to be awesome. I'm looking forward for this. We are here at AI Engineer Summit in New York. We're sponsoring this awesome summit conference, which is like the top AI engineer conference in the world. So please, if you are here also and you're listening to this live, you're probably at the conference right now. So go focus on the conference. But if you're there, come up to our booth. There's 5 of us. We love to talk, as you heard just now, we love to talk about evals. We love to talk about just observability in general, LLM, AI engineering, agents, all of these things. We are looking forward to speaking with all of you about those topics at the AI Engineer Conference, which is awesome. Again, so shout out to the folks at Swix and Ben and everybody who organizes this incredible conference. We are also, I'm having a talk tomorrow. Tomorrow's Friday. So my talk is at 11 a.m. tomorrow. I need to still prepare for this. As Leonard mentioned, I'm going to do like an analysis and research into whether reasoner models are better LLM judges. As we saw, at least in the expert QA example that Leonard posted, they are, but it's not entirely the full story. So if you're interested in a little bit of my research and the approach that we have into understanding judges, more than free to tune in. I'm going to add the link to the show notes, but it's on the AI Engineer YouTube channel. It's going to be at 11 a.m. tomorrow. And so those are the things. And then the last thing that I want to tell you before I move on is that we're leaning into agents, folks. 2025 is the year of agents and reasoning, and agents at work is the name of this AI engineer conference. And we at Weights and Biases are also leaning into agents. We want to understand where we fall short, etc., on agent evaluation and agent observability, which is a topic that everybody's asking us about. So we've released an agent white paper. It's on our socials. You're more than welcome to check this out. And we're also are doing a agents course in collaboration with OpenAI. With Elon Biggio from OpenAI, we're doing an agents course. So 1b.me/agents. This is the way to pre-sign up to our course. And I know folks are loving our courses, especially folks who are listening to ThursdAI. 1b.me/agents is the pre-sign up for our course. It's going to get released very soon to talk to you practically about how to build agents with observability in mind and evaluations as well. If you're interested in any of this, please check out our socials on 1b.me/ the weave_WB on Twitter, which is, if you're listening to the show on Twitter Spaces, it's co-host. And if not, I'll add this to the show notes as well. So this has been this week. Let's talk about the rest of the stuff that happened in this week. So we had the interview because I had to be mindful of my guest's time, but let's talk about the rest of the stuff that happened in this week. Open source AI, let's get it started. A little bit about the open source LLM area, but there's a bunch of open source that happened that are not necessarily LLM related. And one of the hugest ones was Microsoft's Muse. Microsoft's Muse it's honestly crazy. The videos of this crazy. Let me make sure that you guys are watching what I'm watching. They have built and released a model So while Nissan figures out the feedback situation, I want to talk about Microsoft Muse because it's mind-blowing. Basically, I'm going to share a friend of the pod's, Rowan Chang's kind of tweet about this. Microsoft released a model that can generate minutes of gameplay from a single second of frame and controller actions, which is, again, I'm going to say this slowly. You give it like a single second of a gameplay of any type of game with all the screen elements, with percentages, with health bars, with all of these things, and their model generates a game that you can control, which is crazy. Have you seen Muse? Now I can hear you. Cannot hear you at all. Listen, mute, microphone's off. We'll solve it, folks. We'll solve it. This is my kind of like traveling conditions as well. You guys should see the setup. I'm here in this hotel room with multiple things. We'll figure this out. The cool thing about this, they call this WHAM, World. I have it somewhere. Let me see. World and Human Action Model. Yes, thank you. Actually, World and Human Action Model.
It's the 1.6 billion parameter model. It's pretty cool. I've played with it before.
Have you generated? Cool. Have you generated a playable game?
No, that is not. No, that is not the. But so we had. So I don't know if I'm supposed to say this, but like we were working with Qualcomm recently, and they had access to this WHM model, a variant of this. It's 1.6 billion parameter model, and it's pretty cool. Like for its size, it's just I can just say that it's very nice.
Yep. So they obviously have access to. Yeah.
Is my audio okay now? Oh, okay.
Yes.
I saw someone drive around the city. And first I was like, what are they doing with the wheel? Why is it so slow? But then they're like, this is all generated. So that was pretty nuts. They were using a little driving simulator and trying to drive around and generate a city. It's progressing pretty fast, eh?
It's crazy.
Because we saw Doom at first and we were like, okay, but it still looks weird. But now it's starting to become a thing. Yeah, it looks like eventually UIs are just going to be completely fully generated and not
fully composed. Yeah, that's what Jensen says, right? Jensen always talks about everything you'll see will not be rendered, will be generated. This is in the same vein, and this is a tiny model, and it's the cool thing about this. Finally, like it's open sourced. It trained on 1 billion plus gameplay images because again, Microsoft has Xbox in the cloud, and then it learned from real Xbox multiplayer matches, which is I found it super cool. So if you played Xbox lately, you know that you probably are ending up in this model as well, and you can play with it. It's definitely absolutely cool. We also have some state-of-the-art video stuff as well in the open source model. So skipping from what else is interesting about Muse, because before we skip, it's open availability and open source, and you can play with this. And I don't know how game designers feel about this one specifically, but hopefully this will allow them to maybe explore their games before they fully complete.
Small point that you can run it in a free collab notebook if you want.
That's awesome. Yeah, send it. We'll add this as well. The other thing in open source as well.
Oh, yeah.
Go ahead, Nissan.
Sorry, because I can relate. Did you guys talk about Omniparser 2? Because their team has been on a roll lately.
Yep. We didn't actually cover Omniparser last week, I believe, right?
Yeah. It came out randomly. It's becoming like practically usable now. Like not just as a demo that works, but it's starting to look like it's deployable.
So Omniparser 2, for folks who don't know what this is.
So it just draws squares around. It's not that different from having a language model and a projector and a visual, like a clip encoder. And so you have a visual model, projector, and this is how, and an LLM. And this is how most of the multimodal ones are, not all of them. But what this one does is it outputs the coordinates for the squares and for the rectangles and the color of the squares and the labels on the image itself. And now it's very accurate. And in particular, it was accurate with spreadsheets and being also able to tell all the empty cells on the spreadsheets. So we might finally start to meet accountants after 40 years of trying.
as we're coming to the tax season, I don't want my accountant to hear about this. Actually, I need to go find one. So OmniParser is a GUI control library, and here's a great result. I just took a screenshot of our interface for StreamYard where we record the show, and I just pasted it in there, and it looks nuts. Like they detect every little button in there. They detect every little just every little thing in this detected. So basically, you can then use this to control your mouse. And this is similar to what Operator is doing. They called it Computer Use Agent, QA. So this is similar, but OmniParser is in the open source. You can run this yourself. You don't have to go through a specific OpenAI model. So this will be used for controlling your PC or Mac. Or
I used OmniParser 1, and it looked very cool, and it was impressive, but it wasn't that reliable. So it wasn't always accurate. You had to often go back on whatever actions you clicked. But this one is looking much more accurate. Yeah, this might be the one that actually starts getting really, really deployed. Might even rival whatever the MCP protocol, whatever Cloud was doing with computer use.
Yep. All right, so we're moving on. So OmniParser 2, definitely check it out. It came out February 16th. So yeah, within our time frame. We're moving on to the video stuff. There's two very interesting things in video, and I want to talk about like the state-of-the-art video 30 billion parameter text-to-video model, which 30 billion parameter for text-to-video is huge. Most of them like 5, 6, 7, like 12, 13. StepFun released Step-to-Video text-to-video, and they also Step Video T2V Turbo. They released both of these. These look, they released papers with like a bunch of folks, 204 frames in length, and then they also have like turbo version. And I want to show some videos here. They look quite good. I'm very like, let me see if I can.
Dude, this is MIT licensed. I'm just checking.
Yeah.
Hugging Face now.
MIT licensed MIT licensed video model that absolutely looks and does text as well. So here's an example of text, which we are seeing a video of a Chinese girl opening up a scroll, and on the scroll is written, "We will open source." And you can see the text expand as she opens it. It's very very realistic in nature. Those are very short frames. They also have, we're looking at a video of Steve Jobs, for example, talking as the camera kind of rotates around him. And then behind the scenes, it says like step video is coming on the actual screen. And there's like Apple logos that are true to nature that looks like Apple logos. So for an MIT license, we're also looking at a boy turning into Venom from Spider-Man, and like with dripping like wet signatures. This is an MIT licensed video model that also has a turbo variant and also a technical report as well. So if you're into this, I specifically think they're highlighting the text. If you're into this, the previous state of the art, I believe, in open source video was Hunyan Video, which we're going to talk about next as well. But StepFun, 30 billion parameters is not a small model by any means. It looks dope. So shout out to folks. It looks like the Chinese labs went ham this week with a bunch of releases because it uses almost 80 gigabytes of memory to generate, let's say, frames or so. So less than 5 seconds, I believe, less than 5 seconds. Yeah. So very close to, 8 seconds of video. 8 seconds of video, which is like what the state of the art of video releases. So that's StepFun. And you can actually try this. They have a link to try. We'll add to the show notes as well. So you can try and generate a bunch of videos on un.cn, and then you can see like other generations here as well, and they look good, folks. They look good. Very impressive. This is pretty cool, right, Mason?
Came out right before Sora came out, people would have lost their minds.
Yes, if this comes out before Sora was announced, people would have not get excited about it. Like I will put some videos in the newsletter in the show notes. They look awesome. Very much trained on Hollywood films. I'm pretty sure that nobody here cares about copyright. Yes, and the fact that it's open source, I will not mention this directly, but you know what this means. You guys know what this means when you can fine tune on these models, and then people release all kinds of things. So the other thing that I wanted to mention, also in video, is that How AI released fast video, which is making HY video 3 times as fast with no additional training. So you guys remember this whole this whole area where Stable Diffusion was released, and then Stable Diffusion Turbo was distilled from it and was like way, way faster. And then Flash's DXL, like all of these, we talked about multiple iterations of diffusion models getting like faster and faster. And folks, just once something is released in open source, we've seen this with R1 right now. We've seen that, like Perplexity is getting R1 and fine-tuning this. Once something is released in open source, this is how the community then comes in and like tries to extract this. So Fast Video released a version of HY video from Hunyan, which is just 3 times as fast. And it looks pretty much the same, almost entirely the same. So we can see an example, and on the left, you have the Hunyan video, and it takes 15 minutes for 8 seconds. And this model gets pretty much the same results with just 5 seconds. This doesn't require, they use sliding tile attention to reduce the inference, and they also made other models also fast, and they have open distillation methods. So this is a distilled version, right? Do not be confused. But now there's a way here to actually improve without fine-tuning with the sliding tile attention, which is 0 quality loss, no extra training required. This is crazy. This is like rope. Remember rope when it came out and it had this one weird trick that you can use to extend the context length of the model? This feels like this for speed.
Yeah, they're using a FSDP for training too, which is interesting because it's the same technique that a lot of language models use. So I'm interested to see like how are they targeting layers in it for this. It's very interesting, at least from the GitHub there. It looked like they were borrowing a lot of the techniques and putting them together. I'm just wondering, that's 5 minutes for an 8-second video on what GPU, but it's probably just a household GPU.
Yeah, HY video, I think people got it down to household GPUs, but I'm not entirely, I haven't run it myself like locally. I just run it like in the cloud. So they call the sliding tile attention, and then they say accelerate attention alone by 2.8 up to 17x over flash attention 2, and from 1.6 to 10x over flash attention 3. So they have a very specific like attention mechanism for this thing, which is, I think, like absolutely dope. And they released it open source, and you can use it. They call it the kernel, and then you can download this in their GitHub. So we'll add this as well, and then you can inference with the sliding tile attention.
But now you just need a $500,000 rack of H200s at home, and you can play Director. You can do it.
Yeah.
It's just that and move.
So I will say another thing that we glossed over, Nistan, I don't know, remember if we talked about this. HY video, Hunyan video, supports LoRa's. So this is because this is an open source one, you can fine-tune HY video to whatever you want. And if folks want to go a little bit and not safe for work or not safe for podcasts, ThursdAI, if you go there and you just look at LoRa's for HY video, you will start to understand why some, like a lot of people who want waifus, they want videos of those waifus doing all kinds of things. And so HY video is now trainable. You can not only do NSFW work, you can also do celebrities, for example. You can do yourself. You can train a video model on yourself, which is right now only top labs kind of support. And so this model, this distilled version of sliding tile attention now also supports the HY LoRa's. So that's cool. You can generate videos based on your own stuff. We're moving on because the last thing that I want to talk about here before we get to tools and others and we conclude the show, because also AI engineers in town. Figure just announced breaking news today. I actually want to use breaking news button. AI breaking news coming at you only on ThursdAI. So our breaking news from this week is Figure Robot, the humanoid robot company that is we've been waiting and we've been talking about. They have previously signed a deal with OpenAI, and we've talked about this. The robots actually showed the OpenAI animation in their face. Recently and very publicly, they said we're breaking our deal with OpenAI because we have our own stuff to announce. And today they announced it. They announced Helix. It's a vision language action model, VLA model, vision action language that integrates perception, language comprehension, and control to enhance humanoid robots. The video for this is like super cool. They ran 2 robots. Let me see if I can pull this up. Figure. Yeah, let me go to X super quick and then show you Figure. Basically, they have a video, and I don't know if you watched this already. Figure of 2 robots, both of them running the same version of Helix. And this guy comes up to them and is, hey, Figure robots, here's a bunch of stuff that you haven't seen before: eggs, onions, whatever, milk. And then these robots start to collaborating on this thing together because the same neural network runs across both of them. So you can see one robot handing the thing to another robot, which so far I think we've seen humanoids just doing the stuff on their own. And so I haven't seen a humanoid robot hand off stuff to the other one. So one is standing closer to the fridge and one is just giving them stuff to do. It's painfully slow. So obviously a human can super quickly do this. But hey, if you're not at home, why wouldn't this robot do it for me? So basically what we're seeing is they dropped a bunch of stuff. Some of them need to be refrigerated. Some of them need to be put in a drawer. So cookies in a drawer, onions in the refrigerator, ketchup in the refrigerator. And these robots supposedly haven't seen this before. I found it like super futuristically cool. I don't know, Nissan, what's your take on what you're seeing right now?
I have a good take and a back take.
Give us the bad first. I like the bad one.
You want the bad first? It looks like founders in San Francisco that don't have a dishwasher in their apartment might finally be able to expense for a nice humanoid to wash the dishes in a sink because they haven't automated that yet. But
I'm really hoping that like their hands are waterproof.
On the other hand, I am excited about this because as population gets older and stuff, we're going to need a lot more of these. I never said it publicly, but I always thought even 6 months or a year ago that whenever Figure was announced that they will end up just making their own models for this because they're at that point now that they can do it, and they're the ones who probably have the best training data too.
Yep.
And yeah, it was since Moondream was able to run on a single 4090 at 14 frames per second, and I realized, yeah, this is doable now. But yeah, not surprised here, but it's pretty cool that they pulled it off. I'd be more interested to see if they can actually get the whole thing running inside the robot versus an API, but they'll happen pretty fast too.
They are talking about this, and I think they're running one of them on the robot. They're showing a graphic here called System 1, System 2. As you guys maybe know, the thinking fast is slow kind of comparison.
It says they have a 7 billion parameter for the VLM, and they have an 80 mil. I guess that's either the sensors data because it's a bit small to do vision. Yeah, they have a 7B VLM. I would guess is probably just a coin fine tune because that's Apache 2. Why wouldn't you use that? And the other one, the 80 mil, that's their own thing.
80 million transformer, which is like nothing.
Yeah,
that's what they call the System 1, and that runs at 20 hertz. From the robot, like inferences, like everything. But I believe it's for control. It's not for vision because you can't fit vision on this. And then the 7 billion parameter VLM, that's they call System 2 on the second GPU. Listen, it looks like it runs on the robot. It doesn't look API-ish, right?
Yeah. If it's a 7B, it does probably run on the robot.
And so it understands
bigger.
stuff like text commands. So for example, pick up the butter and hand it over to the robot on your left. This is a 7B VLM that runs it.
It says how many tokens per second? 7.9 hertz. So that means it's about 8 TPS. Yeah, they probably got like a 4090 in there. You could probably do that. Cool.
This is so cool. This is absolutely cool. Just the fact that like the robots are handing things to each other, like the system how it breaks between the two robots, I found it like very, very cool. They trained fully end to end. What's more interesting here, they built like a streaming interface to those, and just the results are absolutely amazing. So we will definitely add this to the show notes. You guys should see this. The handoff coordination between the robots is huge, and then the ability for the robots to pick up some stuff they haven't seen before based on what you say to it. So from natural language to an object that they haven't seen before, the generalization of this is absolutely crazy. And they have a bunch of discussions here with high efficient training, a single set of weights, and then we'll add more to the show notes about this, but this looks very cool. I think that's mostly it in the vision and video area that I wanted to cover. I think that this is pretty much it, folks, for today.
So released a better compressed DeepSeek R1 because the VLLM, for the audience, is how most production workloads, VLLM is very common software stack to run inference on the server. So now they support 8-bit FP8, but it would cause quality drops before, and Neural Magic, the company, made a much better quality, much lower loss compressed version of DeepSeek to run on VLLM that works well. And there were a whole bunch of other RL fine tunes which are looking very, very good. I
Seems
even
like
made
everybody is doing RL and fine
Yeah.
tunes.
I made one which was for the 3B model. It took 35 minutes. I just used the Google Colab, just edited like 3 lines. It worked. I took the 3B coder model and it was reasoning. Pretty interesting. You just got that magic and you just copy paste 2-3 pages of it, change one thing here and there, and boom, you have a revolutionary technology no one had before.
Yep.
Yeah, there's that.
So that's basically it. That's our show for today, folks. I will say that because this week was mainly highlighted by Grok news, and also, we have to talk about OpenAI's open source Sam Altman poll. Sam Altman went online the same day that he knew that Grok 3 is about to get released from XAI, and posted a poll that, as OpenAI always love to do before other releases, to take away a little bit of the excitement of the week, posted a poll whether or not, if they release anything in open source, should that be a small model that's like mobile optimized or a O3 mini level intelligence model. And there was a whole debate among our friends and peers about like, why would you want a mobile optimized model when we can quantize this? Give us the higher intelligence one. Well, first of all, Nisa, what did you choose? And second of all, what you think about this open source attempt from OpenAI finally?
I wanted both just to see what
Yeah, I answered both as well.
Yeah, what kind of architecture it would have. I was leaning more on the larger model too, because again, if it's like an O3 mini type that you can just run, that would be very useful to pair with other large models for customer work and so on. Because if you're doing something like customer facing, and you do want the censorship at the very end, but you don't want the model itself to be hampered by censorship, you can just do both. So I am still pretty excited about this. There's some rumors it might be a 14B. So if it is a 14B, whoever had those leaks was right. And
wink, wink.
Yeah, and we have no idea what architecture. So this will be interesting to see. But I did call it last week that after the DeepSeek release, that everyone started to understand that they can have pretty close to leading edge technology and be able to own it. OpenAI and probably Anthropic too is not going to have a choice but to start open sourcing some models if they want to retain influence globally. So,
and we're going to be here for all of this. We're going to let you guys know about the open source and how it works. Speaking of Anthropic, especially because Grok is going to get released. So the Grok is committed, XAI is committed to releasing the previous version of Grok in open source, and DeepSeek came out and like absolutely turmoiled, and people do want to run models of very high caliber that were born in the West. So we're looking forward for OpenAI's actual open source coming soon. The other thing that comes through this is that Anthropic also has upcoming news very soon. So probably next week we're going to talk about some Anthropic stuff. We rumored reasoning model that's unified is coming from Anthropic very, very soon. So we don't do speculations, but this is now pretty much verified from multiple places, including like the information, etc.
I started doing some quick comparisons last night of deep research from Perplexity, the deep search from Grok, and deep research from OpenAI.
Yeah.
Nothing comes close to the OpenAI one.
Deep research is absolutely
deep research is on a league of its. The model itself was not as good by itself, but was really good with the RAG system, because they probably have the best RAG system right now because they just pay everybody else. And
Grok does, you mean?
Yeah, Grok.com.
I agree. I've tested multiples of theirs. I will say this once again. I said this at dinner last night for AI engineer dinner. Grok vibes are hard to understand properly, because if you look only at X, there's a lot of Elon Musk's fans. Let's call them fans. Dick riders is another word to use. They are only posting positive things about Grok for the chance for Uncle Elon to repost them. And it's really, really hard to understand whether or not they're like actually doing this. However, 1 million contacts, which I didn't know going into this talk, is great. Grok, again, as I said before, even Grok 2 is incredible in the RAG system. It has access to X real-time information, it has access to Reddit, has access to a bunch of stuff. So it's actually like very decent. So we're going to end the show on what we started the show on. This is a very big release from a company. They caught up to OpenAI, at least in some areas, very quickly. So impressive team, impressive release. Grok 3 is now built in to X and is a standalone Grok.com and has an iOS app and soon a Mac app as well. So they are firing on all cylinders, catching up to OpenAI after not that much time is very, very impressive. Getting open source out of it is also impressive. So we're looking forward for that. And we're looking forward for an API as well. So we'll be able to actually evaluate Grok on our own stuff and maybe play with it within Cursor or Windsurf, etc. So yeah, very, very interesting. Speaking of Windsurf, look out for the next ThursdAI, because we'll likely have an interview with the Windsurf people. I met Kevin last night and they're here at the AI Engineer Conference. If you are listeners to the show and you're in Toronto and you're willing to weather the weather, we're actually going to do a workshop with AI thinkers on Sunday and Monday. So I'm very much looking forward to that, of meeting ThursdAI listeners, meeting for the first time face to face. Hopefully you can make it on, and we will do some evaluations and networking as well with the AI thinkers in Toronto in a few days, in a very cold Toronto in a few days. It's been cold all around, from Denver to New York to Toronto, pretty much below zero in all of them with some snow, but we will persevere. I think that this is it. Listen, any last words of wisdom about February 20th?
All good. Fly safe. But they cleared up most of the snow.
Oh, nice.
It was like half a meter of snow. Cybertrucks were getting stuck outside. Some kid got lost in the snow in Quebec. Like the whole kid. It's just like not. Yeah. He came out alive, but
lovely.
God, yeah.
Lovely.
Anyway,
so I'm hoping that out of the 270 something registered to our workshops, at least 30 will make it through the snow, but hopefully it cleared up.
No, we pay our taxes. The streets get clean. You'll make it. It's fine.
Yeah.
But yeah, see you there.
The whole kid. That's great. All right, folks. Thank you for joining for ThursdAI for February 20th. If you tune into any part of the show, not the whole show is going to get posted on everywhere you get your podcasts. Please subscribe and give us 5 stars. Reviews. Newsletter probably is going to come out very thin today because I need to run to AI Engineer and actually meet some folks as well. I will add all the links of what we talked about, but there won't be like a longer break. Again, I will shout out the community. Lincoln, President Lin on Twitter, has been collecting pretty much everything that happened, and so shout out, very helpful for me to prepare the show, but also for you to actually know what happened as well. Give them a follow, give the host a follow. Huge thanks to Haize Labs, folks who came up and talked about Verdict and generally their approach to LLM as a judge. They're great. Give that a try as well, and we'll see you next week, where I'll be back at my usual place, and then we're going to talk about hopefully Anthropic reasoners. We'll see. Safe. Have a great day, everyone, and we will be back next week. Bye-bye.